So as we kind of went over in the last two videos when we were discovering what the graph of a log looks like, we saw that the range of your log was the same as the domain of the exponential. And we already know that the domain of the exponential is all real numbers, which means the range of every log will always be all real numbers as well. We also discovered that the domain of your log is the same as your range of your exponential. Now, because your exponentials have a horizontal asymptote, it puts a restriction on that range. Because the range is the same as the domain of a log, we have a restriction on that domain as well. So in this video, we're going to discover how to find the domain of a log by just looking at it. Range, not a problem, but the domain we've got to be careful with. And I put down here that the domain of a log function consists of the positive real numbers. So the log function must be greater than 0. Notice it says greater than and not greater than or equal to, just greater than. So we've been dealing with only 2 mathematical commandments of domain for 3.5 modules of this course. Now, the last half of a module, we now have a 3rd commandment of mathematical domain. So not only can we not divide by 0, and we can't have a negative under a radical, what is within a log must be greater than 0. So in example 3, when it says find the domain of a function, write your answer in interval notation. All we care about is this log right here. I'm going to take what's in that log. In this case, we have x minus 4, and I'm going to set that greater than 0. And now solve. So add that over, and we get x must be greater than 4. So in interval notation, that will be 4 to infinity. Okay, that 4 has parentheses because it cannot equal 4. And you can try that. If you put this in your calculator, if you do the natural log of x, or let's do 4 minus 4, plugging in that number here, we get a domain error. But if I do the natural log of 4.01 minus 4, no, I guess that's too close. I was trying to prove a point and that didn't help, did it? Let's do the natural log of 4.1 minus 4. We get a value there. Okay, I guess that was too small. But technically, that should be fine. Just too small of a number. Okay, so must be greater than 4, but it cannot equal 4 because that will be an error. So that kind of backfired a little bit. But anywho, same thing here. We have a log. And so notice it doesn't matter if it's a natural log, a common log, or a log with any base. All I care about is what's within that log. So I take what's within it, x plus 7, and set that to be greater than 0. So subtract that 7 over, and we get x must be greater than negative 7. So in interval notation, that is negative 7 to infinity.